This is a demonstration of the Reagent system, which enables you to interact by voice and pointing with ordinary web pages that contain no special instrument. As part of this demonstration, we will be building an ontology using the terms and information found on the pages. In cases where Reagent is unable to relate your terminology to content found on the page, it provides simple mechanisms by which you can teach it your domain vocabulary. To start with, let's open a web page containing a table that includes information about the Premier League teams. Watson, open the 2018 table of the Premier League. We see here that we've opened a page from the Sky Sports website for the Premier League. After opening the page, the Reagent system injects a transparent layer on top of it, detecting the salient content and associated hidden metadata, attaching listeners for user actions with that content, such as mousing over table cells, and then allowing us to query for and about content and manipulate it. For example, we can mouse over this row here and ask the query, Watson, who is this team?
The team is Tottenham Hotspur.
And the system is able to accurately respond by detecting the row that we have just interacted with, and then associating the term that we are asking for, team in this case, with a header in the table. However, we see that this table uses abbreviations for many of the headers. In some places, such as this first column, the table has a title attribute for this header to give more information for what it stands for. So for instance, we can mouse over it, see this tooltip, and it says position. And Reagent is able to exploit this tooltip to understand that this column stands for position. However, this column here, for example, does not have that hidden metadata. And so Reagent is unable to understand what this column D might stand for. So a human expert, using the system for the first time, without realizing that Reagent might not know what this column stands for, which is draws, might ask the query after interacting with, say, this row here, Watson, how many draws are there?
I'm sorry, I cannot find a column of draws. Let's identify a column for it.
As we can see, the system was unable to answer the query as it does not understand, or it could not find content on the page that related to the term we are asking for. And the system asks us for help in filling this gap in its knowledge. To understand which of these columns the system does or does not understand, we're going to add it to our ontology. However, before doing that, let's get rid of this last column here, as it's not really an attribute we care about within our ontology, and so we just want to remove it altogether. And we can use the Reagent system to do this. Watson, delete this column.
Column deleted.
And now that we've removed that column, we can add it as an ontology by first gesturing over this column here and then issuing the query. Watson, add this table as an entity using this column.
Added table as entity team.
And so the system, using the term this column, looks up to see what the header of the column was, which is team, uses that as the entity name, and then all other columns in the table as the attributes for this entity. And we see here that this entity that we've added has many attributes that are just abbreviations. So this D, A, F, L, etc. And so the system requires the human to step in and identify the columns for the entity. And to do this, we can mouse over each column in turn and tell it what the term actually is for the column. So for instance, for this column D, we mouse over it and issue the query. Watson, identify this column as draws.
Updated column is draws.
And we see here that the D in our ontology is gone and has been replaced with draws. And so now that we've added that terminology for this table, we can mouse over a row and ask the query, Watson, how many draws does this team have?
The draws is 7.
And the system is now able to understand what the term draws stands for in the table and answer queries about it. And now we could go through every column in the table that still has an abbreviation, but in the interest of time, we'll leave that step undone. And the next thing we'll look for is looking at the rosters for one of these teams. So we'll mouse over the row for Manchester United and issue the query, Watson, open the roster for this team. And we see here that we've opened a page from the ESPN website for the Manchester United squad. And so ESPN, unlike Sky Sports, follows proper accessibility stuff and has appropriate hidden metadata to tell us what each of these columns are, which the Reagent system can exploit to understand what the column content stands for. And so to demonstrate this, we'll just immediately add it to our ontology. Watson, add this table as entity player.
Added table as entity player.
And we see that there are no abbreviations for any of the columns in the table. So we can, mouse over this row here and ask, for example, Watson, how many appearances does this player have?
Appearances is 3.
And the system's able to identify the column we're asking about, this APP, using the hidden metadata, and answer it appropriately. However, looking at these two tables, we see that the goalkeepers table, this top one, has a unique column S to it for saves, and the outfield players has 3 unique columns, G for goals, SH for shots, and ST for shots on target, that is unique to it. So while this table, or this entity, was made from the goalkeepers table and has the saves entity, we are missing the goals, shots, and shots on target attributes for the player entity. And so we can use Reagent to merge these two tables into one entity. Watson, add this table as entity player.
Added table as entity player.
And so now we see that we have in our ontology shots, shots on target, and goals. And the system, given this query, merged the two entities together as, except for these 4 unique columns, the rest are the same. And so the system understands that these are the same entities and should be merged as one. And so now, to finish our ontology, we're going to add a relationship between the two entities we've added. Watson, add a part of relationship between team and player.
Added relationship.
And so now we see that we've added a part of relationship between team and player, and that as part of that, team has gained the attribute team to capture that information. And so using now this completed ontology and the linkage that Reagent knows between this page here for the roster and this outer page for about the teams, we can issue more complex queries that deal with information on both pages. For example, we can mouse over a player here and ask the system, Watson, how many wins does the team of this player have?
The team has 19 wins.
And we see that the system was able to parse our query and answer accurately with 19 wins. Doing this through understanding that we are asking about the team attribute for a player. It looked through the columns of the table, did not find team. However, the header of the table had this term Manchester United, which corresponds to an entry in this table here for teams, and then corresponded the term wins within this table here to the appropriate row. And so this is a demonstration of the Reagent system. Thank you.